Hi, welcome back to Algebra 2. This is Lesson 5 in Unit 5. Unit 5 is all about Unit 5 is all about quadratic expressions and quadratic equations. Today we're going to look at solving equations using the square root and by completing the square. So when a quadratic equation is of the form ax squared plus c equals 0, that means that there's no x term. There's not like a plus 3x or minus 2x. There's just an x squared. We can actually use square roots and we don't have to factor. And in fact, sometimes we wouldn't be able to factor and we can use square roots instead. However, we are going to need to be careful because the square root of x squared is not x. It's the absolute value of x. The absolute value of x. And you can confirm that by simply using a graph like from Desmos or making a table of values, that when you put in a negative number for x and square it, it becomes positive. Like, for example, if x is negative 2 and you square it and get 4, and then the square root of 4 is a positive 2. So when x is positive, yeah, squaring it and square rooting it undoes each other. But when x is negative, squaring it makes it positive. So we need to remember that's the absolute value of x. And we're going to do a little trick. We're going to kind of skip some steps to make it easier, but I want you to know what we're doing and why. So let's take a look at this first equation. I've got x squared minus 9 equals 0. Well, we could factor this as a difference of 2 squared, x minus 3, x plus 3. But I want to use a new technique of the square root. So what we do is we isolate the x squared. And then what we're going to do is take the square root of each side. So as long as we do it to both sides, we're okay, right? It's still balanced. Now the square root of x squared is the absolute value of x, and the square root of 9 is 3. But if you think all the way back to Unit 1 when we solved absolute value equations, we solved this by setting it equal to the positive 3 and the negative. If you think about it, the absolute value basically just takes away a negative sign for real numbers. So like the absolute value of negative 3 is just 3, but the absolute value of regular 3 is also 3. So when we solve this, we have to say it equals negative 3 and positive 3. So both of those values are in our solutions. Of course, if we solved this by factoring, we would have gotten both of those answers as well. Let's take a look at the next problem. X squared minus 8 is equal to 0. So again, I'm going to isolate the x squared. Note that we couldn't solve this by factoring because this is not a difference of 2 squared. The 8 is not a perfect square. Now, we already discussed that the square root of x squared is the absolute value of x, which means we have to set it equal to the positive and the negative. And so we're going to kind of squeeze these two steps here together, and we're going to take the plus or minus square root of each side. So you'll hear algebra teachers say, if you take the square root of both sides, you must use plus or minus. Why? Because the square root of x squared is the absolute value of x. But we just kind of squeeze it together and say we're going to take the plus or minus square root of 8. And that symbol means both positive and negative. Well, let's try simplifying this radical. 8 is 4 times 2, which is 2 times 2, right? So I've got a pair of 2s. So 8 is 2 times 2 times 2. And the square root of 2 times 2 is just a regular 2. So for every pair, I get to bring one out. So this is plus or minus 2 times the square root of 2. So in our solution set, our two answers are 2 times the square root of 2 and negative 2 times the square root of 2. All right, let's take a look at the next problem. We have 4x squared minus 27. I'm going to move the 27 over to the other side and divide both sides by 4. And now I'll take the plus or minus square root of each side. So I end up with plus or minus the square root of 27 over 4. So how do we square root a fraction? We square root the top and we square root the bottom. So the square root of the top, square root of 27 is not a perfect square, so we just write root 27. But the square root of 4, we're lucky enough, is just 2. Now the 27, we might be able to do something with that. That's 9 and 3, which is 3 and 3. So we can simplify it to 3 times the square root of 3. Remember, for every pair, after I factor 27 into a product of primes, for every pair I get to bring one out in front. So it's plus or minus 3 for the pair of 3's. There's still a 3 left over on the inside. all over 2. So in set notation, I have 3 root 3 over 2 and negative 3 root 3 over 2. All right, let's talk about x squared plus 9 is equal to 0. Well, let's isolate the x squared. Note that we couldn't solve this by factoring because this is not a difference of two squares. It'd have to be x squared minus 9, not x squared plus 9. Then I'll take the plus or minus square root of each side. But the square root of negative 9 is not a real number. So there's no real root or no real solution here. Either one we could say. All right, I want you to do practice 5.1. So do each one of these problems. I think we got 5 of them. So start with those and then pause the video. And then we'll go over them. And you can pause it again and do those. All right, good luck. All right, let's see how you did. So you should have moved the 72 over to the other side and taken the plus or minus square root of each side. And we can try and simplify this. 72 is 9 times 8, which is factors to 2 times 2 times 2, and 9 is 3 times 3. So we're going to have a pair of 3s and a pair of 2s and 1 2 left over. Remember, when you bring things out, when you have more than one thing to bring out, they times on the outside. So this becomes plus or minus 3 times 2 is 6 times the square root of 2. So my solutions are 6 root 2 and negative 6 root 2. All right, next we have 9x squared minus 16. So this is 9x squared is equal to a positive 16. X squared equals 16 over 9. And we'll take the plus or minus square root of each side. And the square root of 16 is 4. And the square root of 9 is 3. Remember, we take the square root at the top and the square root at the bottom. And this time it worked out to be just fine. And we noticed we could have factored it. So because we could have factored it, we didn't have square roots in our answer. So we have 4 over 3 and a negative 4 over 3. All right, let's take a look at the next one. No way you could solve this next one by factoring, though. Just going to have to use our square roots, I'm afraid. Which is fine. That's what we're practicing, right? So that's x squared equals 25 over 3. And I'll take the plus or minus square root of both sides. And I get x equals plus or minus, we take the square root of the top and the square root of the bottom. The square root of the top is 5, and the square root of the bottom is the square root of 3. But we're not supposed to leave a radical in the denominator. So let's rationalize the denominator by multiplying by itself on top and bottom. And then we're just going to multiply 5 times root 3 is 5 root 3. On the bottom, the square root of 3 times the square root of 3 is 3. Square root of 3 times square root of 3 is square root of 9. Square root of 9 is 3, so they just cancel out. So in solution set, you should have 5 root 3 over 3 and a negative 5 root 3 over 3. All right, next we have x squared plus 8 equals 4. So we'll use square roots. I'll subtract 8 from each side and I get x squared equals negative 4. So x equals plus or minus the square root of negative 4, but we can't square root a negative. That is not a real number, so no real roots. Remember, roots means solution to a quadratic equation. All right, last we have 5x squared plus 7 equals 4x squared plus 32. I'll subtract over the x squareds, and I get 5x squared minus 4x squared is x squared. 32 minus 7 is 25. And take the square root of each side, I get plus or minus 5. Which is negative 5 and positive 5. So before we move on to something else, it's important to remember the following when using square roots. First of all, there must be no x term. Second of all, the square root of a negative number is not real. And when taking the square root of both sides of an equation, you use plus or minus because the square root of x squared is the absolute value of x. Now let's take a look at another kind of problem. What you consider this equation, x squared plus 4x minus 6 equals 0. So why can we not solve this equation by factoring? We can't use square roots because of the 4x, right? But if I try and factor it, well, let's think. I could do x, and then the numbers that multiply to 6, well, we could use negative 3 and positive 2. But that would give me negative x, so that's not right. Maybe negative 3, it would be negative 2, positive 3. Well, that just gives me a positive x in the middle. then we give me x squared plus 3x minus 2x is still just positive x. So we could then try x minus 1 and x plus 6, but that's not going to work either because that gives me a positive 5x. And likewise, if I do this, it doesn't work either. It gives me a negative 5x. So it's not factorable. That's quite literally, why can't I solve it by factoring? Because the expression is not factorable, right? So when a quadratic equation cannot be solved by factoring, we can use, amongst other things, a process called completing the square. So before we go into completing the square, let's make sure that we remember what it means to complete a square. So I've got this kind of a neat website here where they have these, it's called cpm.org, and they have some online algebra tiles, which is pretty cool. And so I've got x squared plus 6x plus 10. That little caret symbol means squared. And I'd like to represent it geometrically. So if I have a tile, x, we were going to say that this tile x has an area of x because the length is x and the width is 1. And x times 1 is just x. So an x squared tile will have a length of x and another length of x. So it makes a square of area x squared. So I'm just going to put that right there, okay? So that's my x squared. And then I'm going to put 6 x's out there. They kind of lock in place. Isn't that nice? All right. So I've got all that. And then I've still got this kind of a plus 3 going on, right? 1, 2, and then 3. I'll put them like that. All right. So how do I complete the square? I want to make this into a square. Well, the first thing I'm going to do is I'm going to turn this sideways, which, of course, they're not letting me do. Maybe I have to go somewhere else to do that. Okay, so, when in doubt, right, read the instructions. So that's what I've done, and I think I'm back ready to go. I'll go back to my algebra tiles here. Okay, so we have 1, 2, 3, 4, 5, 6. I got to double click. I don't know why I didn't figure that out earlier. Okay, so I'm going to move 3 of them over here. Okay. And there we go. So now it's a little closer to a square, and I've got these 3 little tiles here. And notice that each one of these was a side of 1, so they fit in perfectly, just like that. But what am I missing, right? I'm missing some tiles here. How many more do I need to add? Well, I need to add 1, 2, 3, 4, 5, 6 more to make this x squared plus 6x plus 9, which is a perfect square trinomial. Why? Because look at the factors. X plus 1, 2, 3 times x plus 1, 2, 3. So this must factor as x. Once I filled in and completed this square, I was able to factor it as a perfect square trinomial, x plus 3, right? All right, let's do another one more time. I just want to show you no more tricks so you see the pattern maybe. Let's say I had x squared plus, I don't know, 8x plus 10. So what would I have to add to make this into a perfect square trinomial? We've got this x squared again, right? And then we've got 8 x's. So I'm going to put half of them here, right? And I'm going to put the other half over here. Oop, made it negative. And this process works with negatives as well, by the way. Then I'm going to fill this up as close as I can, right? To make this a square. You got 1, 2, 3, 4. Then I'm going to have another 4. Notice that once I divided by that 8 in half, it was a length of 4 by 4. So we know we need 16 tiles, right? So I need a full 16. So it turns out in this case, I need to, let's see here. That's 10 right there, right? So I'm going to have to add another 1, 2, 3, 4, 5, 6 to make this a perfect square trinomial. So if I change this to 8x squared plus 8x squared plus 16, it factors as x plus 4 times x plus 4, which we know as x plus 4 squared, right? Okay, so what all does this do for me? Well, let's check it out. Let's go back to this problem. What I'm going to do, and I can do it in lots of different ways, but I found that it's the easiest in this situation if I just move that 6 over to the other side. So I'm going to say x squared plus 4x is equal to 6. Now, do you remember this x squared plus 4x? That was like it had a square there, and then I got these 4x's. Well, I'm going to put 2 there and 2 there. So that process there is taking half of that number. So take half of it, and then this empty gap here is that halved number squared. So take half of 4, and then square it, which in this case turns out to actually be 4 again. So half of 4 is 2, and 2 squared is 4. But when I add to one side, I got to add to the other to keep it balanced. Now this factors as x plus 2. X plus 2 times x plus 2 equals this. Notice that this number should always be half of that number and the square root of that number. Then those need to be the same thing. And it'll always take the sign. Whatever this sign is, that's what sign will go here. Okay, so that's x plus 2 squared is equal to 10. Now, because I've got no non-squared x, I can take the plus or minus square root of both sides, which gives me x plus 2 equals plus or minus the square root of 10. Now we can try and simplify the square root of 10, but it doesn't have any pairs in it. So I can now, I'm solving for x, so I need to subtract 2 from both sides. So I get a negative 2 there, plus or minus the square root of 10. I could have said plus or minus root 10 minus 2, but I think that looks prettier. So my two solutions are negative 2 plus the square root of 10 and negative 2 minus the square root of 10. Okay? I think it's worthwhile, though, that we check to see. This is kind of a weird solution. I'm not going to make us check all the time because it's kind of cumbersome. But this is a weird kind of number, this negative 2 plus root 10. How could that possibly be? Well, let's take a look. We have negative 2 plus the square root of 10 squared. So that means this, right? That's what squared means. Plus 4 times negative 2 plus the square root of 10, right? Then minus 6, and somehow that's supposed to magically equal 0. Well, let's FOIL this. Negative 2 times negative 2 is 4. Then that's a negative 2 root 10. Then that's a negative 2 root 10 as well. Remember, don't multiply numbers in the radical with numbers out of it, so it just goes right in front. Then square root of 10 times the square root of 10 is 10, because the square roots cancel. Now over here, I'll distribute, and I get negative 8. And then I get, let's see here, plus 4 root 10, then minus 6. Okay, so 4 plus 10 is 14, minus 8 is 6, minus 6 is 0. So all those whole numbers are gone. Then I've got a negative 4 root 10 plus 4 root 10. Well, what happens there? Well, those go away as well. So it's just 0 equals 0, which is exactly what we wanted to show. Kind of cool, right? I'll leave you to check the negative 2 minus root 10. All right, pause the video and practice this technique. Remember, get the 3 on the other side, then it's half of 6 and square it added to both sides. All right, let's see how you did. Remember, we're going to get the x squared minus 6 alone, 6x. We're going to take half of 6 and square it. So half of 6 is 3. 3 squared is 9. So I add 9 to both sides to complete the square. And then I get x minus 3 because it's going to be half of that number, which is the square root of that, but it takes this sign, squared, equals 6. Take the plus or minus square root. You get x minus 3 equals plus or minus the square root of 6. So x equals 3 when I add it over, plus or minus the square root of 6. So 3 plus the square root of 6, 3 minus the square root of 6. All right, let's do another example. So warning, sometimes you have to use fractions and sometimes you have to simplify radicals. So just be aware of that. And let's do this. Okay, x squared plus 7 equals 10x. Well, if we get the 10x over here, we could try and factor it. That would always be easier, but there's nothing that multiplies to 7 that adds to 10. So I'll just put that 7 right back over on the other side and use completing the square. So I'm going to take half of 10, which is 5, and square it, which is 25, and add that to both sides. This factors as x minus 5 squared, and a negative 7 plus 25 is 18. We'll then take the plus or minus square root of both sides to get rid of the squared. But 18 is 9 times 2. And if you're clever, you can realize that the square root of 9 is 3, so we know this is going to be 3 root 2. As soon as you get a perfect square, you can bool it out. So when I move the 5 over, we're going to say x equals 5 plus 3 root 2, and 5 minus the square root of 5 minus 3 times the square root of 2. Just to put in set notation there. Okay, let's take a look at the next one. 2x squared plus 8x plus 1. All right, I can't factor this. You could trust me, it's never going to happen. So we're going to have to use completing the square. And I get 2x squared plus 8x equals negative 1. Now, it turns out that trying to complete the square with a number in front of x squared is like, I don't even know how to do it. It's probably really hard. We want to have just an x squared so that things are nice. So what we're going to do is we're going to divide by that number in front of x squared. So we're going to make this x squared plus 4x equals negative 1 over 2. So I'm dividing all terms. Got to divide both sides, every term, by 2. And yes, it gives me a fraction, but that's okay. Now we'll do our completing the square process. So you take half of the number in front of x, which is 2, and square it and add that to both sides. Now 4 is the same as 8 over 2. This factors as x plus 2 squared, and then this is 7 over 2. So I'll take the square root of each side, and I get x plus 2. I don't need the parentheses anymore, do I? X plus 2 equals plus or minus the square root of 7 over the square root of 2. Remember, when you take a square root of fraction, you square it at the top, and then you square it at the bottom. I'm going to multiply by the square root of 2 on top and bottom. And I'll bring that over here. So I have x plus 2 equals the square root plus or minus the square root of 14 over 2. Remember, that's how we rationalize our denominator. So my final work is negative 2 plus or minus the square root of 14 all over 2. Be careful that that over 2 is clearly outside of the radical, okay? If you want to be extra certain, make it a 1/2 in front of it. So we have negative 2 plus 1/2 and negative 2 minus 1/2, root 14. 14, by the way, in case you're wondering, is we know is 7 times 2, and there's no pair, so it doesn't simplify. All right, let's try letter C. Okay, a little trick. If you multiply the 2 and the 5 together, you get 10. You can check if there's anything that multiplies to 10 and adds to 10, but there's not. So this is not factorable. Okay, so I'll do that. I'll go ahead and divide through by 2 so that I can get a single x squared. Now I'll take half of the middle number. Half of the middle number is 5 over 2, right? Now I got to square that number. Remember, the process is take half of this number and square it. So I got to square 5 over 2, giving me 25 over 4. And when I add the one side, I got to add to the other. So this is a negative 5 over 2 plus 25 over 4. Now I'm going to need to add those. So if you'll prevent me to just get a common denominator here, I'd like to go ahead and do that. I'm going to multiply the top and bottom by 2, okay? So that'll become a 4, and that'll become a 10. So this is a negative 10 over 4. This will factor as x plus, it better be half of that or the square root of that. Either way, it's 5 over 2 squared equals 15 over 4. Take the square root of each side, plus or minus. You get x plus 5 over 2 equals plus or minus square root the top, square root of 15. Square root the bottom is 2. So x equals negative 5 over 2 plus or minus the square root of 15 over 2. So negative 5 over 2 plus the square root of 15 over 2, and negative 5 over 2 minus the square root of 15 over 2 are our roots. All right, for a practice problem, I'd like you to demonstrate why x squared plus 4x plus 8 equals 0 has no real valued roots. Give it a try. So I have x squared plus 4x plus 8 is equal to 0. Let's move the 8 over to the other side. We'll take half of 4 and square it. Half of 4 is 2. 2 squared is 4. And add it to both sides. But when I do negative 8 plus 4, I get negative 4. This will factor as x plus 2 squared equals negative 4. But when I take the square root of both sides, square root of negative, which is not real. Because we don't square root of negative. It's not a real number. Practice 5.4. Solve the following using completing square. Okay, give it a try. Pause the video, please. All right, let's see how you did. We have x squared minus 20x equals negative 20. Going to take half of 20, which is 10, and square it, and I'll add it to both sides. So it gives me 80 on the right. This will factor as x minus 10. Remember, the square root of 100 is 10. Half of 20 is 10, but you take this sign here. Take the plus or minus square root of each side. Now we got a square root 80, but 80 is 8 times 10. 5 and 2. 2 and 4. 2 and 2. I got a pair of 2's there. I got a pair of 2's there. So we have two pairs of 2's. When they come out, we get a square root of that is a single 2 times a single 2 is 4. So this is 4 root 5, plus or minus, I should say, 4 root 5. So our solutions will be 10 plus 4 times the square root of 5, and 10 minus 4 times the square root of 5. All right, see if you can find the roots of this equation. Okay, so notice it's got a 2 in front of it. You could try and factor this, but it does not work. But we can't complete the square of the 2 there, so we'll divide through by 2 and get x squared plus 4x equals 5 over 2. Take half of 4, which is 2, and square it, which is 4, and add it to both sides. So I'm going to add this as 8 over 2. This factors as x plus 2 squared equals 13 over 2. Take the plus or minus square root of each side, and you get the square root of 13 over the square root of 2. But we're not going to leave it like that. We'll multiply by root 2 over root 2, giving me plus or minus the square root of 26 over 2. So my solutions will be x. My solutions for x are move the 2 over, and it becomes a negative 2. Negative 2 plus root 26 over 2. Negative 2 minus root 26 over 2. And those are our solutions. And if memory holds, that's our last problem for today. And I'll see you in the next lesson.